this picked point must have this following three properties. One is, on that particular isoquant, the factor price ratio determines which point you pick on that isoquant. The RTS must be equal to the factor price ratio. And also, on the other curves we generated here, it must have the following property. The factor price, the ratio of factor price to output price must be equal to the marginal productivity at that point. Okay. Similarly, if you hold x1 as a constant, you must have this property. So that's the bottom line of this, the solution to the profit maximization problem. In each direction, okay, the slope of this curve must be equal to the slope of the production function surface. There are three directions. One is horizontally, so you have the slope of the isoquant. And also vertically, you have two directions. One is holding x2 as constant. So that slope is marginal productivity with respect to the first factor. That marginal productivity has to be equal to the ratio of the factor price, x1 and p. Okay? And then in another direction, okay, this marginal productivity has to be equal to the corresponding factor output price ratio. You see that? Okay. So which point that maximizes profit really depends on the three prices here, R1, R2, and P. So that's why, essentially the solution, x1, x2, and y are written as functions of P, R1, R2. Okay. When one of those prices change, then your optimal solution will change. And this comes to the core of price theory, economic analysis. Essentially, when we're trying to determine why x1, x2, x1, x2 basically tells you how the firms use the resources. They are the factors, right? And output, y, determines how much product is supplied to the market. So those behaviors are determined by price. Price contains the information about scarcity of the goods or resources. So the economic agents, they respond to the prices. If the price, for example, if the price of the product increase, look at here, what would happen to the solution? Well, it doesn't change this way, right? You're still on the, maybe not this particular isoquant, but the factor price ratio must still be equal to the slope of the isoquant. But when price increase, look at here, what would happen to this line? Shift this way, right? Okay. Wait a minute, price increase, the slope will decrease, so this way. Okay, that means I'm moving in this direction. Okay, so that means y will increase. x1 will increase, okay? Similarly here, when price goes up, it becomes flat, okay? And then y will increase, x2 will increase. So I'm moving here from this point to this point. But because the factor price ratio remain the same, I'm still on the expansion path, okay? But my y will increase. Because y is increased, x1, x2 is also brought up. So this is like, for example, using a real-world example, if the price of cotton has increased, we are going to imagine, we can predict, okay, in the future, land use will be increased in cotton production, and water resources will be increased. Okay. So if producers expect the cotton price will continue to rise, okay, they will respond this way. What if output price remains constant, but one of the input price becomes input becomes more expensive. Let's say R1 becomes higher. When R1 goes higher, okay, this probably remain the same. R2P, this remains the same. But R1 goes up. Okay, look at here. So it becomes steeper, this line. So you will see the Y will decrease, X1 reduced. Because the factor becomes more expensive, of course you're going to use less of that factor. Okay, so output is brought down because of you use less of that factor. And here, because of the price goes up, you're going to use less of X1, but you're going to use more of X2. So move this way. So on this graph, okay, when R1 price goes up, probably you're going to move to a lower isoquant, but here, a little bit more of X, well, more of X, less of X1, more of X2. You're going to move here. Okay, a lower isoquant, but a little bit towards X2, because factor 1 becomes more expensive. Okay, so when one of the price changes, you're going to move around this surface. Okay, because of the towards the direction where you can lead to another different equilibrium. And another point I want to emphasize, okay, these equations, how this x1, x2, and y change in response to a price change, really depends on the technology, the production function, right? If you have a very different production function, the response is going to be different. Okay? So I want to emphasize this again is because usually we estimate factor demands of supply functions. But you want to understand the property of those functions depends on the property of the production function, technology. If you have a different surface, okay, the response will be very different. For example, if this line is flat, not those curve, not that much curvature here, it's a little bit flat, okay? Then if the price of R1 goes up, so your response will be much dramatic because it's flat, you're going to move quickly. If it's very curved, very much curved, your response is going to be very slow. Okay. So the properties of those functions, eventually, oftentimes we can estimate those functions. But what I want to stress here is those properties depend on the shape of the production function. Okay. Another observation I want to make is this one, okay, the lambda. Lambda, we actually have always left this lambda. We didn't pay much attention to lambda. Okay. But there's an economic interpretation with lambda here. Just compare this first order derivative, okay, the first order condition, with this one. Okay. Compare this with this. And compare this with this. What do you have found? Yeah. So if lambda, okay, listen, if lambda is equal to P, then cost minimization is equivalent to profit maximization. If lambda is equal to P. Okay? But we also know if P is equal to marginal cost, cost minimization is equivalent to profit maximization. So what is lambda? Marginal cost. Okay. The Lagrange multiplier is marginal cost. In the cost minimization problem. Okay. To see that more clearly, okay, remember when we solved the cost minimization problem, we set up the Lagrangian function. P R1 X1 one.